Venus is one of the last planets to be explored because of its ultra-thick atmosphere. It's ironic because Venus is the most like Earth in size and place in the solar system. Compared to Earth, its diameter is 404 miles smaller. Its density is 0.9 that on Earth, and its gravity is 0.8 times on Earth. Venus's orbit is approximately 224 Earth days, with a rotation period of 243 days. So, strangely enough, a day on Venus is longer than a year on Venus. It also rotates backwards, and the sun rises in the west and sets in the east. But it is still, nonetheless, one of the most similar planets to Earth. Because of its similarities, exploring Venus gave scientists the chance to see how a planet similarly sized might have evolved in comparison to Earth. Venus and Earth are often called twins because they are similar in size, mass, density, composition, and gravity. However, Venus is one of the last planets to be explored because of its atmosphere. Because it's difficult to see past it at a telescopic level, early astronomical documentations of Venus were of solely the atmosphere's appearance. However, although it appeared to be filled with water vapor clouds, like our Earth, it proved to be made of carbon dioxide with clouds of sulfuric acid fog, unlike Earth's oxygen and nitrogen-based atmosphere. Because of its atmosphere, Venus proves to be a hot, volcanic, and suffocating entity. In its entirety, it is about 49 miles high, with a 25-mile clear region, 12-mile deadly cloud layer, and another sparse 12-mile layer of clear atmosphere. The atmosphere moves quickly around the planet from east to west, making a full circle in about 4 days. They move in the same direction that the planet spins, but about 60 times faster. The sun's heat is what drives the clouds around Venus. As the gases are warmed at the equatorial regions, they rise and move toward the cooler regions at the poles, where they cool down, lower, and move towards the equator and repeat. This is known as the runaway greenhouse effect, which is where the term greenhouse effect came from. Venus's surface temperature is 867 degrees Fahrenheit, which is 720 degrees higher than it would be without an atmosphere. Venus's surface is relatively flat, with elevations less than ones found on Earth. It is composed of plains, mountains, faults, ridges, rift valleys, volcanoes, and a few impact craters, proving to be a highly complex surface. Certain highland regions are known for the complexly faulted orthogonal patterns and are recognized as tessera, which is the Greek word for mosaics of tiles. The Diana Chasma Rift Valley is similar in size to the Great East African Rift Valley and the Rio Grande Rift Valley on Earth. But because there is an absence of erosion on Venus, all structural details are perfectly preserved. Venus's surface is also made up of several large volcanoes, which appear similar to those on Earth. The surface of Venus appears to be dominated by volcanic hotspots. Impact craters are evenly spaced about the planet with only 900 recognized. The low number scattered about the surface implies that only the last 20% of the history of Venus appears to be preserved, and little is known about the earlier surface geologic history. Missions to Venus didn't even start until the 60s. These missions started with Mariner 2 which was a flyby that used infrared wavelengths to test the surface temperature and found carbon dioxide in the atmosphere. The most recent expedition to Venus is an orbiter called the Venus Express. It has observed Venus for over 8 years. It focuses on the structure, composition, and chemistry of Venus's atmosphere. The mission confirmed that Venus is losing water from its upper atmosphere and that it may have been much more humid and Earth-like. Some observations were taken of the surface terrain by using the visible and infrared thermal imaging spectrometer. The data shows the best evidence to date that Venus has been volcanically active in recent geological times. In the upper atmosphere, large variations of sulfur dioxide have been discovered. The Venus Express is expected to continue its mission in 2015. The satellite is reported to be in excellent condition and a major scientific achievement in not only learning about Venus, but also operating a probe so close to the Sun. It will be extremely useful in preparation for the upcoming
Bepi Colombo
mission to Mercury.